In this lesson, we're actually going to be solving some logarithmic equations. Now, in the first few, we're actually going to use that same one-to-one principle we used in the last video. Step number one, we're going to condense the logarithms on each side of the equation, the same as we used our rules of exponents. We're going to use our rules of logarithms there to condense them. Step number two, we're going to use that one-to-one property that if the log base b of x is the log base b of y, the only way that could be true is if x and y are the same. So we're going to actually kind of mark out our logs and only worry about the arguments. Step number three, we're going to solve and check for extraneous solutions. And reminder that on that step three, the way that we're going to check for that, you cannot take the log of 0. You cannot take the log of a negative. Anytime that you plug back in and you have the log of a 0 or the log of a negative, we're going to have to throw that answer out. So number one, let's go ahead and get started. Again, one-to-one, anytime you have the log of the same bases equal to two things or equal to each other, we can actually just worry about the same way we worried about the exponents in the last one, we're going to worry about the arguments here. The only way that these two things could be equal is if 7x minus 1 is equal to 5x plus 17. Same way we set the exponents equal to each other in the last lesson. You see what we're doing here. Move the 5x over by subtracting. Move the minus 1 over by adding, and you get that x is equal to 9. Again, checking for extraneous solutions. When you plug that in, just make sure that you don't have the log of 0 or a negative. We're fine there. Here, the natural log of something equals the natural log of something. The only way that that could be true is if the arguments are true. K squared minus 4 would have to equal k plus 14. This is quadratic, so let's move everything to the same side. Subtract your k, gives you a negative 5k, and move plus 14 by subtracting 14, and we moved everything, so equals 0. Two sets of parentheses. K times itself gives you k squared, adds, multiplies is a negative 7 and a positive 2. So k is either 7 or k is a negative 2. Now, I said we couldn't take the log of a negative. However, k is negative 2. If you were to plug that in, it gives you a, let's see, it'd be a negative 2 squared would be 4 minus 4 times negative 2 would be plus 8. 4 plus 8 is 12. That's fine. Negative 2 plus 14 here is 12. It's fine. So even though the k is a negative, when you plug it in, the argument is positive. So both of those are fine. When you plug in 7, you get 49 minus 28, which is 21. Same thing here. Both of those terms are fine. Just make sure you don't get a negative or 0 when you plug it in. Here we do have to condense. Your product rule of logarithm says if you have a log or plus a log, you can condense those by multiplying the arguments. That'd be the log of 4c plus 12. Let's put that in parentheses so we know that we're taking the log of the whole thing, equals the log of 8. Since you have a log equal to a log, set your arguments equal to each other, the one-to-one principle. 4c plus 12 is equal to 8. Let's subtract our 12, and that gives you 4c is negative 4, so c would have to be negative 1. If you were to plug, this is the only place you can plug in c. Negative 1 plus 3 is 2, so that one is okay. Number 4, a log minus a log. You have your quotient rule here. We're going to rewrite that as log base 7 of w plus 6 over 5w minus 3. We do have to condense those to a single logarithm. Same thing on the other side. You have the power rule that says you can take this back up to a power. And that'd be log base 7 of 8 to the 1/3, which is log base 7. 8 to the 1/3 power is the same thing as the cube root of 8, which is 2. So let's go ahead and clean that up. Now, same thing, you have a log that's equal to a log, so let's set our arguments equal to each other. W plus 6 over 5w minus 3 is equal to 2. Solve this by getting rid of division by multiplying. W plus 6 equals, when you multiply by the other side, make sure you distribute. Put it in parentheses. So that would be 10w minus 6. Let's move all of our w's to the same side. I'm going to move this one by subtracting. That gives you 9w. Move this one by adding. Gives you equals 12. Move the 9 by dividing, and you get w is equal to, let's reduce that fraction, divide top and bottom by 3, and that gives you 4/3. Going back and looking at where we plug it in, as long as we don't get 0 here or here, we don't get a negative, we're going to be fine. And you could try 4/3 and you're not going to get a negative, so that's a legitimate answer. Number 5. Nothing has to be done to the left side. Log base 4 of 4p plus 3. The right side, we are going to take this 1/2 up and write it as a power. So that's 16p to the 4th. Raise it to a 1/2 power. We can distribute it and raise both of them to the 1/2 power. And reminder that a 1/2 power is the same thing as a square root. To raise a power to a power, though, we're going to have to multiply those, and that gives you p squared. So 16 to the 1/2, that would be, let me write log base 4. 16 to the 1/2 is 4, and then you have your p squared. Now we're good with setting the arguments equal to each other. 4p plus 3 equals 4p squared. Let's move everything to the same side, and since the p squared over here is positive, I'm moving everything to the right side. So 4p squared, subtract your 4p and subtract your 3 is equal to 0. You're going to have to use your slip and slide factoring here. Let me change colors, and I'm going to come over here and do it. That'd be a p squared minus 4p. Slip the 4 to the end, gives you a minus 12. Two sets of parentheses. You got a p times itself, adds, multiplies, is a negative 6 and positive 2. You slip the 4, so now divide by it. Both of those, neither one of them will divide, but they will both reduce. So that'd be p minus 3 halves, and this would be p plus 1/2. You can now slide the bottoms, the denominators, back up front. You have 0 equals, two sets of parentheses, a 2p minus 3, and a 2p plus 1. Set each of those equal to 0. 2p minus 3 is 0. 2p plus 1 is 0. Add 3 and divide by 2 here. That'd be p equals 3 divided by 2. Subtract 1 and divide by 2 gives me p is equal to negative 1 divided by 2. Now let's see if both of those are going to be legitimate answers. We've got to make sure that when we plug them in that we get positives, and it's not going to be any trouble plugging in the 3 halves to give us positives because we have 4 times it and then plus 3, that'll never be a negative. When you raise it to a 4th power and multiply by 16, that's not going to give you a negative, so we're going to be fine there. The negative 1/2, the only thing, let's plug it in here, 4 times negative 1/2 would be negative 2 plus 3, which is a positive 1. And we know it's got to be positive here because when you raise it to a 4th power, that's going to be a positive value times 16 then. So p equals negative 1/2 also works out. Okay, next up, let me slide over here, number 6. Zoom back in. First thing we need to do is let's go ahead and condense this on the inside. And we can go ahead and move this 2 up to a power. So we have the natural log of a plus 1 squared equals the natural log of 80 minus the natural log of 5 would be the natural log of 80 over 5. So that'd be the natural log of 16. Now this can actually come up into a power, and that'd be the natural log of 16 to the 3/2 power, and that will clean up again. So let's do that. Natural log of a plus 1 squared equals the natural log 16 to the 3/2. Bottom number is a radical. It says you're taking the square root, and the top number is an exponent. So the square root of 16 to the 3rd, that would be 4 to the 3rd, which is 64. Now let's set the arguments equal to each other. We have a plus 1 squared equals 64. And I left it like that because we can actually just take the square root to get rid of it. So you have now a plus 1 equals plus and minus the square root of 64. Move the 1 over by subtracting gives you negative 1 plus and minus 8. So my two answers here would be negative 1 plus 8 and negative 1 minus 8, which is negative 9. Now let's check those two answers to make sure we're fine. When I plug in 7 plus 1 is 8. That's fine. This is the only place I have to plug it in. However, something bad happens when I plug in negative 9. Negative 9 plus 1 is negative 8. You cannot take the log of a negative value, so therefore we're going to throw out the negative 9. That's an extraneous solution. Next up, what if we don't have a log equal to a log? We can't use that one-to-one property now. So here's what we're going to do. We're still going to condense and isolate the logarithm. We're going to rewrite the equation in exponential form now. Okay, anytime you don't have a log equal to a log, we're going to rewrite it in exponential form, and we're going to solve from there. And again, check for extraneous solutions. So here we go. These are all condensed. We have isolated the log. So we're going to take this, and the only thing that we can do now is rewrite it. And if you don't remember how to rewrite it, it's the base raised to this power. So we have 2 to the 7th power equals the argument. And now it's just a basic linear equation. 2 to the 7th power is 128, and that's equal to 3x minus 4. Get rid of the minus 4 by adding, gives me 132 is equal to 3x. And when you divide by 3, it gives me x is equal to 44. We can check and make sure that's not extraneous by plugging it in. We can't take the log of 0 over negative. 44 will be fine. Log base e of 2a is equal to 9. Again, remember the log here is of base e because it's a natural log. So we're going to rewrite this. There's nothing to condense, so rewrite it as e raised to the 9th power is equal to 2a. So if you want to leave this as exact, because e to the 9th is going to be a decimal, you could just simply divide by 2, and your answer is going to be e to the 9th divided by 2. If you want that as a decimal answer, you can type that in, and you're going to get about 4,051.54. So you can leave it exact, or you can leave it approximate. Number 9. Log base 6 of w plus 7 minus 5 is equal to negative 3. Now you do have to isolate that logarithm. So the first thing, that minus 5 that we're not taking the log of, let's move it over. Now you have log base 6 of w plus 7 is equal to 2. Now you're going to rewrite it. Anytime you've got it isolated and it's not a logarithm equal to a logarithm, we're going to rewrite it in an exponential form. 6 raised to the 2nd power is equal to w plus 7. Last step, subtract the 7 and gives you w would be 29. Make sure that we can take the, plug in the 29 for a w, and we get 36 here, so we're fine. Next up, again, let's isolate this logarithm. Let's move our plus 4 over by subtracting, and you can actually just do it right here and put a 1. Now, the next step, you have some options here. If you would like to raise this up to an exponent, you could. Or you can actually just move it over to the other side by dividing. Either way is going to be fine. You're going to have log base 9 of k squared plus 2k is equal to 1/2. Now let's rewrite it. The base raised to the number on the other side, that'd be 9 to the 1/2 power is equal to k squared plus 2k. 9 to the 1/2 power. Again, the bottom number is a radical, top number is an exponent, so that's the square root of 9 to the 1st, or just 3. So what we're going to do is we're going to take that and move it to the other side since it's quadratic by subtracting it. It's a positive 3 on this side. You can put it there if you'd like to. Move it to the other side, it's a negative 3. Next up, we're going to factor that. 2 sets of parentheses. K times itself, adds, multiplies is a negative or positive 3 and a negative 1. So set them each equal to 0, and you get k is either negative 3 or k is equal to positive 1. Now let's see if they both are fine. Here's the only place we have to worry about plugging in our k values. When I plug in a negative 3, will I get a negative? That gives me 9 minus 6, which is 3. That's okay. When I plug in a 1, it gives me 1 plus 2, which is a 3. So both of those values, when I plug it in, neither one of them gives me a log of a negative, so they're both fine. Number 11. We do have to condense the logarithms before we solve these. So that's our product rule. So that'd be log base 4. We've got to multiply these two. Now, luckily, they are conjugates, and there is a shortcut for multiplying conjugates. Multiply the first two values, 4v squared. Multiply the second two terms, gives you a negative 9. And you should get a difference of squares whenever you multiply those together. Because, again, difference of squares factors into conjugates. Now we've condensed them, we're going to rewrite them. 4 to the 2nd power, and I like to go ahead and square it as I write it down, is equal to the argument. Notice that there's no v term, so therefore we can solve these by taking the square root. Let's move our minus 9 over by adding 9. That's equal to 4v squared. We then divide by 4. So therefore v squared is 25 over 4. That means v would be plus and minus the square root of 25 over 4. Which is plus and minus. To square root a fraction, just simply square at the top and square at the bottom, and you are done. Number 12. Let's condense these logarithms. First step, the 1/3, let's move it up to an exponent. And 27 to the 1/3 power is the cube root of 27 to the first, which is simply 3. So this would be the natural log of 3 plus the natural log of x minus 5 is equal to 4. We're going to condense these using our product rule. That would be the natural log of 3x minus 15 is equal to 4. Again, a natural log has a base of e, so when we rewrite this, let's use that. That's going to be e to the 4th is equal to 3x minus 15. Now, you can write this answer in one of two different ways. You could write it exact by leaving it as e to the 4th, move the 15 over by adding 15, and then you'll divide by 3, and you could leave your answer like that. Or you could type e to the 4th into your calculator, add 15, divide that by 3, and you're going to get an approximate value of 23.20. Number 13. Again, we're going to condense our logarithms before we start. So we have a log plus a log. That's our product rule. So that'd be log base 2. We've got to multiply those two logarithms together, or excuse me, the two arguments. N times n is n squared. Again, I'm going to save myself a step by multiplying n times 1 and negative 3 times n, and go ahead and combine those. That'd be 1n minus 3n, which is negative 2n, and then negative 3 times positive 1 is a negative 3. There we go. We're now going to rewrite it. You have a log equal to a number, so that's going to be 2 to the 5th is equal to the argument. Move everything to the same side since it's quadratic. That'll be n squared minus 2n minus 38 is equal to 0. Let's try to factor it. Adds, multiplies. And whenever I try to do that, I see that I made a mistake. Up here where I did 2 to the 5th power, I put 35. That's actually supposed to be 32. And when I subtract it, I'm going to get 35. Now that makes it a little bit better. Two sets of parentheses, n times itself, adds, multiplies is a negative 7 and a positive 5. Set each of those equal to 0, and you're going to get n is equal to 7 or n is equal to negative 5. Now, let's look back and make sure we don't have any extraneous solutions, which I believe we are going to have here. When you plug in 7, you're fine because you did 7 minus 3, which is 4, 7 plus 1, which is 8. That's good. When you plug in negative 5, it gives you negative 5 minus 3, which is negative 8, and it also gives you a negative 4 here, so they're both going to be negative, so we're going to have to throw out the n equals negative 5. So you have one solution. Okay, number 14. Condense these two by using the quotient rule. That'd be log base 2 of c squared over 3c minus 5 is equal to 2. Let's rewrite it in exponential form. 2 to the 2nd power, which is 4, equals c squared over 3c minus 5. Get rid of the division by multiplying. Make sure when you do multiply that you distribute. That'll be 12c minus 20 is equal to c squared. It is quadratic, so we're going to move everything to the same side. Since c squared is positive on the right side, I'm moving everything in that direction. The 12c turns into minus 12c. The minus 20 turns into plus 20. Two sets of parentheses. Let's factor. Adds, multiplies. Gives you a negative 10 and a negative 2. Set each of those equal to 0, and it'll give you c is 10 and c is 2. Let's check those for extraneous solutions. When you plug in 10 or 2, either one here, it gives you a 4 and a 100, so that's fine. Plug in a 10 here, it gives you a 25. Plug in a 2, it gives you 6 minus 5, which is 1. So both of those answers will be okay.